This is Miss Triangle. This is the 5-6 angle side angle and angle side theorems video. So make sure you put the date and the topic 5-6 ASA and AAS in the top right. Set up your lines for your Cornell notes. Our EQ, our essential question, what are the congruence shortcuts? So we've already talked about side, 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 and side, angle, side. So we're going to do the last of them today. So what are the congruence shortcuts for proving two triangles congruent? Our learning target 5F, I can use the AAS, angle, side, and the angle, side, angle, ASA theorems to prove two triangles are congruent. So pause the video if you need any more time for this slide. I'm going to move on to the example, or the vocab, sorry. Okay, so you don't need everything, but you need something for angle, side, angle congruence theorem. The picture would work. Please make sure that you note it's an angle, two angles, and the included side. So two angles and the side between them. So it has to be in that order. So if you get angle, side, angle, yes, you can say the two triangles are congruent. Or the last shortcut is angle, angle, side. So that one is angle, angle, side. And you might just want to draw the picture. That would be fine. You don't need to copy everything. It's not needed. But there should be something written down. All right, concept summary. So again, I would maybe do the names and the pictures. So there's 5 methods for proving triangles are congruent. There's side, angle, side, 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 hypotenuse, leg, that's for right triangles only, angle, side, angle, and angle, angle, side. Whoops, angle, angle, side. So those are your 5 shortcuts. Another way to remember is what there is not. So there is no AAA, no AAA, and no ASS, right? That would be a bad word. So those two do not work. All right, here is our first example problem. Can the triangles be proven congruent with the information given in the diagram? If so, state which theorem, like SSS, SAS, you would use. So it's a little hard to see this part A. I'm going to redraw the picture. So basically it's this triangle right here and this triangle right here. And we have these sides marked and these angles marked. So we have an angle and a side. So we always want to think, is there anything we can add? Is there anything we can add? So usually things we can add are like alternate interior angles, reflexive side, or vertical angles. And I actually have vertical angles right here. And then I have angle, angle, side. So I would say yes, using the angle, angle, side theorem. Okay, in part B, we have 3 angles, angle, angle, angle. So go back, look at your notes. Does that work? Angle, angle, angle. Hopefully you're saying no. That's not a shortcut. Okay, and this last one I will also redraw because it's a little hard to see. We know these 2 angles are congruent and this angle. So we have an angle and an angle. We also can add that reflexive side, giving us angle, side, angle. So pause the video if you need more time for example 1. I'm going to move on to example 2. All right, write a proof. Given AD is parallel to EC, and those are the little parallel arrows right here. BD is congruent to BC. Prove the 2 triangles are congruent. So I'm going to go ahead and set up my table. I'm going to start with what's given. Okay, then let's think, is there anything else we can add in this picture? Hopefully you're thinking we can add these vertical angles. So I'm going to go ahead and call those vertical angles. So I'm going to say angle ABD. is congruent to angle EBC, and my reason is going to be vertical angles. So right now we have a side and an angle. We have a side and we have an angle. I also know that these two sides are parallel. So I have two parallel lines cut by a transversal. So I also can add alternate interior angles. Angle D and angle C are congruent. Okay, and then lastly, since I've done angle side angle, I can go ahead and say that triangle ABD is congruent to triangle EBC. My reason is angle side angle theorem. All right, so pause the video if you need any more time for that. Otherwise, I'll move on to the last example. All right, here's our last example, short and sweet today. So draw the picture, draw the diagram, write the problem, write a proof. Given HF is parallel to GK, that's also marked on our diagram, and angle F and angle K are right angles and congruent, prove the two triangles are congruent. So let's think, is there anything else we can add to this picture? We can add the reflexive side in the middle. So I'm going to go ahead and add that, HG. And then since I have parallel lines cut by a transversal, I can also add these two angles. Whoops. And I actually could have done these as well. You just choose. All right, let's set up our statement and reason column. So I'm always going to start with what's given. HF is parallel to GK, that's given. Angle F and angle K are right angles. That is also given. All right, then, since they're both right angles, I can say that angle F is congruent to angle K. And I'm going to say definition of right angles. Okay, so I've done an angle, then I need to do the next set of angles. So I'm going to say angle FGH up here. Is congruent to KHG. And those again were alternate interior angles. Parallel lines cut by that transversal. Then I'm going to do my reflexive side, so HG is congruent to HG, and that is the reflexive property. So now I've done an angle, and a side. So I can end with what it asks me to prove, that the two triangles are congruent. Okay, so pause the video if you need more time. Lastly, the summary. What are the 5 congruence shortcuts? So go back at your notes, look at your video. What are the 5 shortcuts? How do they save you time? If you think back to earlier in chapter 5 when our proofs were like 10 lines because we had to list all 3 pairs of sides and all 3 pairs of angles, the shortcuts all involve only 3 things. A side, an angle, a side, 3 sides, so they definitely are shortcuts. Thanks for watching. Have a great day.